in JavaScript. Christian.
Thank you. So are the web rebels still awake or what? Woo! Does anyone else feel like this web rebel? Because that's what I feel like. It's really, really high. Okay, thank you for that sweet pink goodie bag. So this talk, it's going to be, I'm just going to show you a lot of techniques borrowed from functional programming and hopefully inspire you to create better abstractions for your programs. That's like the short overview of this. So yeah, I work at this company, guitorius.org, where I help create a free open source web application for hosting and collaborating on Git projects. And then I wrote this book. Does anyone know this book? It actually just came out in Japanese. It was translated to Japanese. And I suspect it's going to be a hit because it has a sports car and acid-flavored colors. That's bound to be good. I also do some open source JavaScript libraries. Maybe someone heard of Sign.in.js. It's a sort of mocking thing for JavaScript. And currently we're working on this project, Buster.js, which is a very, it's basically a test framework, but it has a lot more to it, so you should check it out. Anyway, this is about functions, not about test frameworks. So this is one of the simplest functions you can have in JavaScript. And in functional programming, the function is obviously at the front and center. And then there's a couple of concepts we use to describe functions that also help in functional programming. So JavaScript has what is known as first-class functions. So functions can be values like any other value, right? And then there's this other important concept from which the title of my talk comes from, the concept of a pure function. Does anyone know what a pure function is? A few of you. So a pure function is basically just a function that has no side effects. So it only operates on its input, and then it returns a value, and has no side effects on other objects or state or whatever. And the other underlying principle we need is a higher order function. So there's two things that make a function a higher order function. So the first thing is if a function returns another function, we call that function a higher order function. So in this case, you can make an adder, give it a base number, it returns a new function that will add that number to other numbers. Looks like this. The other thing that can make a function a higher order function is if it accepts functions as arguments. And you probably all know this, right? The add event listener interface. Or if you're new to the game, maybe you only know this way of doing it, or any other kind of API that takes a callback. So let's take a look at some examples of how to use higher order functions. And I'm going to start by looking at loops. And I'm going to also say that for the most part, imperative looping structures like this suck. And very often they're not the right solution. And this one too. And the other ones like it. And the reason I say that is that I think there are better options. But first I want to explore why we use loops. What's the point of our looping or the looping structures in our programs? The most frequent use case for a loop is when you want to just enumerate all the items in a list and you want to cause side effects with each item, right? In this case, the side effect is printing to the log of the browser or the console or whatever. Typically, your side effects are more interesting than that, but you get the point. Another use case, in this case, I have a list of tweeps. Does anyone know what a tweep is? No one? So a tweep is a Twitter user. So in this case, it's a list of objects representing Twitter users, and you want to produce a new list that has a list of strings, names of people, right? So you want to like transform the data from one point to another point. Here's yet another example for looping where you start out with a list and you want to just boil it down to one value of another type. Doesn't have to be another type. but in this case, I want to take a list of strings and produce some HTML and put it into the browser. Okay, so what's wrong with loops? Why don't I like loops? Well, first I want to take a loop at the alternative. So most new browsers provide built-in methods on the array objects to solve this kind of problem. So this is the side effects loop, right? For each item, I want to cause a side effect. There's a method called array prototype.forEach. Who has used this method before? A lot of you. Good. So this basically achieves the exact same point, right? Only instead of using a loop, we're calling a function on the array is basically looping itself and calling back to us whenever there's a new item to check out. So what's the big deal? Like syntactically, JavaScript doesn't have a lot to offer in this case. It doesn't get a lot shorter because the function syntax is pretty verbose, right? So that's not a big win. But the big win here is in where the focus of the code is. So in the first example, the code is overly focused on the mechanics of looping and iterating. There's a lot of details about iterating, like what index to start on, what's the boundary condition, how do we need to update a counter, and that kind of takes all the focus. In the second example, the focus is on the side effect, which is the whole point of this loop. Okay, so let's try to summarize why we're looping. We want to cause side effects. Sometimes we want to transform data structures. Sometimes we want to perform filtering, right? If I have a list of Twitter users, I may be only interested in the ones that follow me, because I'm that kind of guy. Or maybe you want to combine items or any variation of these, and I'm sure you can think of other specific use cases as well. And it happens that the browser provides iteration methods like forEach that map very well to each of these cases. I'm not going to show you all of them, but I want to show you at least one more. Map. So whoever used the map method? Oh, most of you, so we can skip quickly through this. So the map function is a loop. It's basically a special purpose loop that allows you to transform a list of data to a list of data of the same length where the values have been transformed some way. So in this case, I'm extracting the name properties. I can use the map function to be more specific or be clear about what I'm trying to achieve and say that the names is the tweets mapped on tweet.name. But still, I didn't really save a lot of characters or whatever. So, but we can one-line this because given that this function has a very short scope, I could typically live with a shorter named variable and I can one-line it. So it's not really a big point that you can one-line it, but I like it as an acid test of the expressiveness of an API. So I can convert a list from a list of objects to a list of strings in one line. That's a good level of expressiveness for me. But I want to do this even shorter or more expressive. So, okay, let me just give you another example first. So in this case, I'm building a string that says mentioned by, and then I want to have each Twitter name separated with a comma, and this will be all the people who mentioned something on Twitter. And this loop is even worse in terms of focusing on looping specifics or mechanics, right? Because now I also have to check that we don't add the separator after the last item in the array. And I don't know about you guys, but when I write code like this, I run into off-by-one errors all the time. So if we look at what we're doing here, we're extracting the usernames, then we're combining them, and we're using a separator. There are dedicated methods to achieve all these tasks. They look like this. You use the map on the list to produce a list of strings. Then you use the join on that list to combine them with a separator. Okay, and now I want to up my abstraction level, right? So the map function here is really only extracting a property. That's something that I do quite frequently. Go from one object, list of objects, extract only one property into a new list. So let's define a higher order function called prop that you can give a string that is a property name. It will return a new function that you can call with an object, and then that function will return the named property. Did everyone get that? Come on. It looks like this. So you say tweeps.map, and then prop name that returns a new function that when you pass an object into it, it will return the name property. And it's actually easier to understand this code from this usage example rather than this definition, because when you read this out loud, it tells you what it's doing. It maps on the name property. So not only are we removing the focus on the looping mechanics, but we're also making it easier for ourselves to see the right abstraction where we can plug in reusable abstractions. So last example, reduce. Who has used reduce before? Show of hands. Okay, not as many. It's a bit more advanced. The example here is that I have a list of buffers, and buffers have length. And I want to figure out the total length of all my buffers. So I bust out my JavaScript for loop, looks like this. But really what we're doing here is that I'm taking that list of buffers, I want to extract the length, and then I want to combine all the lengths into the sum. Almost the same as with my string example, right? So extracting the property, I can do that with map. I take the chunk and I return the chunk down to length. And then to combine all the values, I can use reduce. So reduce will take an optional seeding value, and then the first value of the array, combine them, take that value along with the next item from the value, combine them, take that value along, you get the point, right? So it folds the values into one by one. And in fact, in many cases, this function is called fold or fold left as well. But I'm not done yet. So there are more abstractions for me to recognize here. So this function looks a lot like the first one I showed you. It's called add. And if I already have a named function that does what I want, I don't have to inline it. So we can use that. Cool. What about the other one? That also looks familiar. Prop length. That's basically what the prop function does. It returns this function. And then it looks like this. And now I can one-line it again. Woo! And again, the one line is not the huge point here. It's the expressiveness of the solution. So buffers, map property length, reduce with the add function. If the word reduce makes sense to you, then this reads very well. If the word reduce is hard for you to understand, you could take reduce, add, and define a sum function with it, right? Okay, so I want to move this into async flow control. So who thinks that async flow control is really easy? Yeah, no one. So async flow control is actually very, very difficult. I've been working with Node for kind of a long time, and I'm still kind of struggling a little bit with it. It takes a long time to adjust. So the task that I want to show you here is to fetch some scripts. We're going to do this in the browser. We're going to fetch multiple scripts, and then I want to combine them into one string in the right order. And why is this a challenge? Because I don't want to waterfall fetch them, right? You don't want to get one script and then wait for it to finish loading, put it in the string variable, then get the next one. That's going to take too long. So I want to maximize my network activity and download all the scripts, or at least as many as I can, in parallel, and then combine them. But because they're going in parallel asynchronously, I don't know what order they will complete, so I have to do some manual bookkeeping to get them combined in the right order. It's going to look like this. So in this particular example, you have to combine them in the right order, because if you load backbone before you load underscore, it's just going to stop working. Let's try a solution. We'll bust out our trusty old for loop again. We start with so my bookkeeping solution here is the data array. I'm going to put the results into the correct indexes there and combine that. Do the Ajax call. So I'm doing this in a for loop. That's going to make them parallel because it's asynchronous. And then in the success handler, we'll put the response into the corresponding index in the data array. And then we check that if we got enough results, then I'll combine it and call a callback. First of all, that's really, really, really fucking ugly. And if you write code like this, you should be ashamed. And it's okay. I have code like this. And sometimes you have to have code like that, but you should be ashamed when you have it. So, but it's not only ugly, it doesn't really work either. So did anyone spot the problem? Or one problem? You got to test one. Have you seen the last one? Yeah, so I tried with the length here, but there's a few reasons why this doesn't work. The I variable here is being shared by 3 callbacks when there are 3 scripts, and that means they all seem the same value. So to fix that, we can wrap it in a closure to cache it. Now it's even uglier, and it still doesn't work. I could use for each, which would remove like 1 level of indentation, because then you have the callback naturally. I don't need the anonymous callback. The point is that I can still put lipstick on this pig. It's going to be ugly, and it's still not going to work. So instead, I'm going to use a library that was actually presented earlier today, the async library, which defines for each, map, filter, and all those iterator functions in an asynchronous manner. So what we're doing here is really we're mapping a list of path names to a list of scripts, right, on the web server, and then I want to take those scripts and combine them. And async manages to do this asynchronously by using CPS, which stands for Continuation Passing Style, which is just a very fancy name for a function that takes a callback, and when you call the callback, you're done. So the jQuery Ajax function is not continuation passing style by nature, so we can just wrap it like this to make it work nicely with async. So in this case, I'm not using any options or anything, but obviously you could just add that in as you need it. This is just a simplified example. The point here is that the Ajax function takes the callback as its last argument. And that's going to be called when the request reaches the success state, which will cause async to know that it's done, right? So this also doesn't account for errors. Again, it's a simplified example. And to solve this problem with async, this is all I have to do. Async.map, and then I give it the list of scripts. I give it the function, which is defined in a continuation passing style, and then I give it the final callback, which will be called with an array of results, where async will put the results in the corresponding location from where the script was. And then I can just join it. This is pretty succinct, and at this point, you definitely should realize my first attempt as ugly and a hack. Okay, so I want to jump into partial function application now. Who has ever used the bind function in JavaScript? Like the function prototype bind? Most of you guys. Okay, so this is from an example. This is from an app that I wrote with Magnar Sven, who did the Emacs presentation on Wednesday. And the call object is just like a utility library we wrote for this app. And it has an interface called L, which is an element builder. So when you call DOM L with the tag name, it works just like document create element. You just get a DOM element. So that's not very exciting. But you can call it with attribute properties. And these are properties, not actually attributes. And you can also call it with children, which can be either a string, which will cause call to create a text node, so that will automatically escape all script content, or you can pass it in DOM elements or other kinds of nodes if you want to do that. The thing is that we could rearrange this a little bit, and then it will start looking eerily like markup with the right nesting. However, it's kind of verbose. So we're going to use partial function applications to make this more like a DSL for crafting markup. So partial function application is where you take a function and you bind some of its arguments and produce a new function. When you call that new function, those arguments you originally bound it to will always be passed in first, and then additional arguments will follow. So with call, you can do it like this. You say call.partial, you pass in the function, in this case the add function, and then one argument. This produces a new function that will always call add with 2 and whatever arguments you pass into it. So this is like the make adder thing that I showed you first. So this creates a new function that adds 2 to whatever number you pass to it. So with the element builder, we could use this to bind up the tag names to create a DSL-like thing. So we could say call.partial, and then the element builder, and then the tag name produces a new function that will create UL and LI elements. And now our nesting example really starts looking like markup or whatever. It starts mirroring the same kind of structure that you would put in markups, right? And we actually ended up using this. In many cases, we ended up favoring this over templates because this is still code. So our editors and all our like developer tools understands this and can make sense of it, which is not entirely true for like a string. So because we ended up using this in many places, we realized that we didn't want to like do this and recreate the DSL all over the place. So the library itself also bundles the DSL. So we just enumerated all the tag names that we use the most, did a for each, and inside that, we just produced the new functions. And to use this version of the DSL, you'd have to prefix it with call.dom.l, which is a bit cumbersome, but you could use one local variable in a closure. And then it looks like this, which is not as pretty as it was, but at least you don't have to recreate the DSL when you want to use it. And obviously, we didn't want to have like 30 global functions with names like A. Yeah, you get the point. Okay, so that's one use of partial function application. Another nice thing about functional programming techniques is that when your main method of abstraction is a function, there's a really good chance for you to create composable abstractions. And I'm going to show you another example from the app that we worked on. So this is part of it. So this is like a multi-step form or wizard kind of thing, where you'll see that on top there's 2 sections that have been completed, and then there's a step that's being edited, and then there's 2 steps grayed out down there that's like coming up. So the way that we represented this is that all of these parts is something called a panel. And inside each panel, there's one or more components. So in the case of step number 3 here, there's a title component that has like validation rules and rules about how it can be saved and all that kind of stuff. It's got a description component. It's got 2 date components and so on. And the number of components varies for each panel. And in addition to this, a panel can be rendered in 2 modes. It can be rendered in a summary mode, like the 2 first, or it can be rendered in an editing mode, like the 3rd one. And the 2 at the bottom are actually not initialized yet, so this is just their non-interactive state. Given this screen here, when you hit the Done button, that section goes into summary mode, and then the next section opens. So what I'm going to show you is the code for building the summary to display in the summary mode here. And remember this prop function, I'm going to use this again. We also have a function that's almost like prop called func. Can you guess what it does? So func produces a function that you can pass an object to, and then it will call the named function. So in this case, this will produce a new list where each element is the result of calling toString on the original object. So it's basically a way of dispatching a method to a lot of objects in one go when you combine it with map. So we have the element builder, we have prop, and we have func. And to summarize our panels, we only need this one line here. So we have the div, which creates a div element. Then we have all our components. We map them by calling the build summary function on each one of them. So that will produce an array of DOM elements that we give into the div element, function. So we get a div with some elements inside. And what I like about this is that if you're not used to this way of coding, it's probably going to be pretty dense. But you get used to it and you can read it faster. But what I like here is that all of these abstractions are completely generic, don't have anything to do with any part of our application. But yet I can compose them into something that's very specific, right? And also, this is not obviously not a purely functional approach, because the build summary is a method and an object, and I'm mapping the components list, which is obviously a list of objects. So you're free to combine these techniques as you like. This is just another technique to put in your utility belt. Okay, so this works by calling build summary on all the components. In some cases, that didn't really work out like we wanted. So for some panels, we had to solve the build summary method differently. So the components also has a method called get summary, which returns an object with properties like text and description and some other things. Yeah, so for this panel, we started by crafting the build summary method manually, because now there's not an equally simple solution to the problem. So we create the div manually, and then, of course, bust out our trusty old for loop to loop the components. And then we create a p element, set its text to the component's get summary that gives me an object, and I call the text property, and then you put the p inside the div. So this is almost in a format that can be refactored into the solution that I just showed you, but because the components.getSummary.text, it doesn't quite work. So let's see if there's any better approach to this. Obviously, we could try to use for each, but it's still basically the same approach. If we use map, we get closer to what I want. So once again, there's a div, and then we pass in the components mapped with a function. And this function manually creates a p element, then get summary, get text. But let's take a look. Let's try to analyze the transformation. What are we trying to do here? So we want to get the summary object, I want to get the text property, and I want to put that string in a p element. That's basically what my mapping transformation is. So maybe we could try multiple maps, like expressing each one of these transformations as a single map. This looks pretty horrible, and it's even longer than my original solution, right? But I can recognize reusable abstractions here. So the first one, it calls the get summary method. Okay, I can use the func abstraction. The next one gets a property. I can use the prop abstraction. And the last one, well, it creates an element and puts some text inside it. I can use the element builder DSL abstraction. Now, this is a lot nicer. At least it's very expressive. It's easy to read. It's fairly easy to get what's going on here. But you may be worried that this actually loops the whole collection 3 times. I'm not entirely convinced you should be worried, but you may be. So the solution to this problem was to, instead of doing 3 maps, we use function composition to produce 1 new function so we can do 1 map. And don't worry, I'm going to explain this a little bit better. So take a look at this. I'm going to use named functions because that makes the example a little bit easier to follow. So first of all, we have that get summary func thing. I'll call that call get summary. That's what that function does. The next one is get text. And then the final one is the p function, and the compose function is called summarize. Now, what happens when you call summarize? You call it with an object. The first thing that happens is that we call the get summary function on the object. That returns an object. That value is passed into the get text function, which will say object.text. That returns a string, which will be passed into the p function. Right? So we have our 3 transformations packed into one superpower function that does all these 3 things. And it just takes the input, gives it to the first function, takes that return value, gives it to the next one. It's just a chain of functions, right? And you may feel that the ordering in Compose here is the wrong way around. The reason for this is you can see that in the example here that it maps to what it looks like if we're going to inline it. So we could use this function to spruce up our build summary implementation. So now we just create the map function, and then we can map the components once. And now I notice something else. So that summarize function, that has nothing to do with my object. It has nothing to do with this specific call. It's just like the other abstractions, it's just a generic abstraction that does 3 things in a row. So I can just prepare that function once ahead of time, and then my build summary is back to being a one-liner. And then this is just a small stylistic note. In this call library that we did, we also have a map function that makes sure that the map always works even if you're in the browser where map isn't defined and so on. And that actually takes the function first and then the collection, which works very well if you use named functions. Map, summarize, components. It's just a stylistic thing. Okay, so that's how you can use function composition in practice. So usually when I tell people to ditch all their loops and use these functions instead, people get worked about performance. So I'm going to throw in a very unscientific note on that. And I did like a JS perf thing and figured out that my computer can do 5.2 million operations per second if I use a for loop to loop an array of numbers. Great. If I use for each, I can only do 1.5 million operations per second, which seems horrible in comparison. And reduce, it's about the same. I'd imagine if I run this enough times, it's going to even out. But the thing you should remember is that if your app is even slightly touching the DOM, you probably have more pressing issues to worry about. So I'm not saying that you should disregard the performance issue completely, but keep this in mind. Like, there's relative things to think about here. But then again, if you're on a mobile or in any like environment where performance is a important factor, you should measure and figure out bottlenecks and keep tabs on this. But most of the times, for loops is not going to be like the savior of your application. So my very, very brief conclusion from this, hopefully I just showed you that by looking into functional approaches, you can find some interesting ways of solving problems in your code base. But what I will give as a sort of advice is that when possible, you should prefer pure functions. So if you can prefer functions that only operate on this input and return a value, your code is going to get a lot easier to reason about, and it's going to get a lot easier to test, and it's going to get easier to compose. Similarly, if you prefer generic abstractions, you're going to up the chances of reusing those functions. So the less specific they are, the more you will get to use them. So in my head, it's better to have 3 very reusable abstractions that I can combine in any way than to have one more specific one. And then finally, that kind of follows from that point, prefers small abstractions. Small generic abstractions will compose very well and will allow you to reuse them over and over again. That's it. Thank you.
That kind of looked a bit like Lisp, didn't it? Except with more parentheses.
Yeah, more and more dots.
Okay, any questions? I think it's way too late in the day for questions. Okay, then I see Trygve itching to get the mic here, so I'm just going to give it to him.
Thanks. It's been a couple of great days, I think so. Have you had a good time?